Hello. Sorry for my voice. It's got a bit bad the first day, so you have to excuse me for that. My name is Jonas. I work for Red Hat on the display server slash portal slash GTK slash Wayland kind of stuff. Since we are Red Hat, we are a cloud hybrid native company, something like that. So I thought it was useful to have a talk about what X.Org did before and how we do it now without X.Org. Since it's an X.Org developer conference, it made sense. So I'm going to go into that. I'm first going to define what is the cloud. It's just other people's computers. I think that was something that FSFE defined a bunch of years ago. But I'm going to narrow it down a bit to it's in the context that I'm going to talk about. It's remote desktop to computers without actual monitors and mouse and keyboards. They're sometimes in virtual machines. They're sometimes just a machine in a closet or in a machine hall or something like that. Some of them have GPUs. Some of them don't have GPUs. In the past, everything surrounded X.Org or some kind of variant of X.Org, like XVNC or XVFB or some X.Org kind of fork or imitation, and everything was interacting with in weird ways, like using the test API for input or reading mapping buffers for reading output and doing things like that. And after that, we remove X.Org. All the connections just fell down. There's nothing to replace it with in Wayland. So we needed to solve the cloud workstation use case, but we thought maybe we should start fresh. Since there's no Windows involved, we didn't need to go through the windowing system anymore. But we still need hardware acceleration because that's an important use case. Sometimes, even though it's remote, it has to be very fast and low latency and all that stuff. So since the overall move to Wayland, it unlocked using DMA buffers for just passing around the system. So that was a perfect fit for that. Also taking inspiration from Wayland, making things a bit more descriptive. The desktop environment or the components will know that it's useful for them to know that it's a remote desktop session. It can change behavior and things like that. So it has been an iterative process. We started with screen sharing that you might have used. We first decided to have a unified video streaming using a new project at that time called PipeWire. It was called Pinos when we started doing this work, but it renamed to PipeWire, as you probably know. It's used to plumb camera and now screen content and window content and anything that you have pixels on or even audio eventually. It was designed to be privacy friendly, sandbox friendly, so it's used by web browsers. PipeWire supports all the kind of things that you expect these days. DMA buffers, explicit modifiers, explicit synchronization, and all that nice stuff. For going into the cloud again, we have to do input. In the X.Org days, it was based on mostly X-test or faking hardware with U input. In the beginning, we just had some really dumb debug methods calls, but that was just a stopgap solution to create something more extensible. So we created something called libei. It's pronounced as you pronounce egg in German. I'm not sure it's A, but I think it's A. It stands for emulated input. It became this unified extensible input method plumbing solution that can just plumb input between different processes. Behind the scenes, it kind of took a lot of inspiration from Wayland as well. It uses an XML file to describe protocols, and it generates bindings, and it has a stable wire format, so you can re-implement it with something else if you want. It supports keyboard, touch, pointers, adding tablet and gestures and all that stuff, so eventually. The next step in the process of going cloud is running the compositor headless. We didn't want to involve the kernel too much because there's no need, because there's no display devices that we're going to connect to. So no KMS at all. Still, you need a hardware acceleration, so just use the render node, so we get an EGL or Vulkan context. In our case, it's an EGL context with the GBM platform, and then use one stream, PipeWire stream, and make that a virtual monitor. So when you create a stream, you create a monitor, and you remove a stream, you remove a monitor, and you can have your virtual cloud machine with all the streams and all the good stuff. So the talk is about how this comes to what is this about developing compositors. That makes no sense. But the thing is, you sometimes want to run them nested for debugging window management, or you want to debug anything that is not related to KMS, more or less. Most of the compositor use these days have a native Wayland backend, but in Mother, the one used by GNOME Shell, we don't have that. We have an awful, terribly bad nested backend using the same backend as we use when we are running as a compositing manager on top of X.Org. So we needed something better. So we did consider just adding a Wayland backend, but it would be nice. But it would be kind of a new backend. It wouldn't be a production backend because we don't have an actual use case to run as a nested compositor in production. It would be a bit trickier to add fluff around the like the view. If you run nested, you probably just want to shove the pixels on the screen and be done with it. But it would be nice to have something more. So then we have this cloud platform. It has a fast and a low latency pixel shoveling thanks to PipeWire. It has very powerful input plumbing. It's now already there. It just needs some way to actually view it in the same way as you view, like you run a nested compositor. And the bonus is that you actually test the cloud platform a bit more if you do this. There were some issues. If you just, like the things that I've been describing, the frame pacing and the frame clock has been a compositor side detail. You in the PipeWire stream, you negotiate a frame rate and a size and all that stuff, and then the frame clock in the compositor just pushes frames when it needs to. It works pretty bad when you want to synchronize to the host compositor's vsync frame rate. So something has to be done there. Thankfully, PipeWire has this ability to switch who drives the graph, the way that things are processed. So what made things a lot better here is that we switched the one who is like asking for frames or creating frames, and hook up the damage signaling in the compositor to through PipeWire, so that the PipeWire consumer can know when to request new frames, and then hook this up to the viewer application frame clock, which in this case is a GTK4 application. So I was thinking of trying to see if it's possible to show you. Quick to look. Here is a terminal with my developer environment set up. It's more or less a debug session. And then I run GNOME shell -- SDK, and let's see if it works. Nope. One more dash. And it showed up in the wrong screen. Here it is. So it's this GTK4 application. It has this hamburger menu. You can, for example, switch to emulate touch. So it takes all the touch pointer input from GTK, and you can see now it's a hand. We can pretend that we're touching here. I thought. The demo effect is in progress, I think. It's supposed to show a keyboard, but it's not. Perfect. It's supposed to show a keyboard, so I have actually prepared for this failure of demo. Just going to jump. So this is what I showed you. If you touch with a hand, you'll get a keyboard for it because it's a touch device. So there's the next steps. This is all using our own vendored GNOME API. There's some work in progress to create something more vendorless. It's missing how to control the monitor configuration in X.Org. This is done via an X-random property called, I think it's just suggested X or suggested Y. We need something better here. We need more input devices. We need more like tablet support, for example. In the PipeWire consumer being the one scheduling frames, we now have to round trip through the daemon, which is a bit bad. So there's some work going on towards avoiding that, because normally in PipeWire you don't. It's direct between the consumer and the producer, but the damage signaling is still via the daemon. But that's going to be fixed. And we don't support explicit synchronization in GTK, so that's also something that needs to be addressed. But yeah, that's how cloud and compositor tools get together. Yeah, happy family. Thank you.
Hey, can you hear me all right?
Sorry?
Okay. This is a bit of like a sort of light-hearted comment. I know you know the guy who's the Looking Glass guy. Is anybody here familiar with the Looking Glass project? Yeah, a couple people. I don't know if you've seen this. This is not actually a practical suggestion or like meant to be super serious for production use cases. But I don't know, have you seen there's a project called the Telescope Project, which is Looking Glass over RDMA?
I don't know about it, no.
No, it's like a raw frame buffer with like shared memory that gets sent over like an RDMA switch, like a RDMA over converged Ethernet or like InfiniBand. It's a pretty cool project, probably the most performant implementation you could ever hope to get with remote frame buffers for cloud. But I'm not sure that it would ever be, sending like 40 gigs per second over a network in production. It's probably not very useful, but it's fun anyway.
Actually, I know about an implementation, but it's proprietary that does something like that, but with compressed video. So you get H.264 in the same way.
I was just saying, like, I think there's a compression method for the Looking Glass proxy, the KVM frame relay over fabric thing. It was some university researchers in Brazil or something, some kids that pulled it off. So I don't know, you can check out the project. I think it's like LG proxy. There's like a website for it.
What I was talking about is actually a video compression card that does that. It goes over the network, so you can use it as a display output.
I think the thing is, like, one of the reasons why there's sort of like a level of difference between like the remote display protocol stuff and the stuff that you use for like VMs locally is largely because of the H.264, like, you know, having to compress it, having to decompress it, having to encode and re-encode, where like for quite a while we've been trying to like display virtual machines like using basically network remoting protocols like, you know, Hyper-V or something. You might see somebody using like RDP on a loopback, which makes no sense for local virtualization, whereas remote virtualization and like getting access to a frame buffer over network, you know, you might use something like VNC and, or, you know, and compressing with H.264 because that trade-off makes sense.
Are you familiar with prior art like WayPipe? So WayPipe is basically designed to just funnel one client at a time to a remote server. So you could run Firefox on a remote server and just stream the window data itself to whatever client you want. And it's mostly transparent. It's just going to show up as a Firefox window on the client side. However, you can combine that with a Wayland compositor that is nested, like you were actually talking about, and then you'd actually have kind of what you were demoing. Can you, like, are there specific advantages with your way of doing it over what WayPipe would be doing?
So the main use case for the cloud stuff is a complete desktop frame buffer, and then you composite into the frame buffers in the compositor, and then you share those through the network via RDP or VNC, something like that. So I think the WayPipe is per application, then you can do...
Right, that's why I was referring to using WayPipe in conjunction with a compositor that is rendering in Wayland. So you're talking about that. You said it wasn't production ready. I was just trying to touch on that because I just don't understand why that was...
Like remote desktop servers, they tend to assume they want a frame buffer, or like a buffer.
Yeah.
And then you shove that to somewhere else over the network. But WayPipe is about... I know you said you can put it... pipe it through the network and then show it like you composite them on another compositor. So it's more difficult to do that via VNC because it doesn't have that kind of separation, and it seems a bit like a different way to do remote desktop overall. But like when you do the remote desktop solution, is about just getting the complete frame buffer, and then that desktop environment as well. It gets a bit complicated to use WayPipe.
Well, like if you have a integrated Wayland compositor that is actually just running as a Wayland client, that's just submitting buffers on its surface, right? So those buffers, I guess, would be what you want, and WayPipe would just pipe those through. Anyway.
Something to think about.
Yeah, something to think about.
Yeah, I was just going to say, have you also taken a look at like different transport protocols, like NVIDIA? They did something. It was originally called GeForce Now, and there's been a bunch of reverse engineering that's gone on in the server and the client. They have probably the most performance protocol that I've yet seen for frame buffer transport, like over the network. It's called like the Moonlight protocol. Have you seen that?
No.
No,
never seen. But the platform that I'm talking about doesn't include the remote desktop protocols themselves. It's about you create a remote desktop server on top of it.
Yeah, there might be some use. So there's actually an open source project called Sunshine, which is the server that sends the data. It might actually be used. I don't think they have Wayland compatibility at the moment, as far as I'm aware. Most of the time, people just run it on Windows machines because I think that's where the compatibility is that I'm aware of. Like there might be some use to taking your work and
Yeah.
adding it to the Sunshine project, because then you could have Linux servers, not just Windows servers.
Yeah.
Yeah.
All right.